Hi, this is Larry B., Director of Technical Sales with ProFlow, a division of Process Equipment. And we're here talking about starch cooking and the different processes involved. One of the alternatives to traditional starch conversion is enzymatic conversion, and that can be done on site. Basically, starches need to be converted before they're used on the paper machine, and that can be done by the starch supplier off-site at a tolling facility where they use thermochemical processes to convert the starch before it comes to the mill, at which time it gets cooked to make it ready to be used on the paper machine. This process is very expensive, and it can be subject to supply chain issues. So if the vendors don't have enough material to supply the mill's needs, then that creates operational constraints on production. So one of the things that's available are enzymatic conversion systems, and those can take a native pearl starch and create and convert it on site using safe processes and low temperatures. Basically, we can take the pearl starch, create a slurry, and then we use enzymes, an amylase enzyme, which is very similar to the enzymes in your mouth, to digest the starch. And what that does is it breaks down the starch into chains that can be used, and basically the paste becomes very viscous, upwards of 40,000 to 50,000 centipoise when we add the enzymes. But we allow the enzymes to continuously digest it to the point where we have the correct viscosity, and then we interrupt the enzyme action with even higher temperature. So we'll heat the slurry, add some enzyme, and that activates the enzyme to allow it to digest the starch or convert it. Once we hit the target viscosity, we then elevate the temperature to 250 degrees Fahrenheit, which basically inactivates the enzyme. And then the starch is ready to be used on the paper machine. These applications are typically at the size press, where starch is used as an external coating to the sheet. And so it's important that the size press has appropriate viscosity so that it will apply to the paper consistently. So our continuous enzymatic converter provides for very consistent molecular weight and viscosity of the converted starch by using a plug flow reactor, or basically a long static mixer that allows the starch to be exposed to the enzyme very consistently. So we have a very narrow distribution of molecular weight compared to a traditional batch reactor where we have a tank. These are some of the technologies that were used 20 years ago, where a tank was used to react the starch, and that can provide very broad molecular weight and actually a broad variation in viscosity. It's very difficult to target in a viscosity with a batch type system. With our continuous enzymatic converter, we're able to dial in the viscosity just by simply varying the dosage of enzyme into the starch. Enzymatic conversion can save the mills a lot of money and allow a lot of flexibility in sourcing their starch. They don't need to rely on pre-converted starches from the manufacturers and then be subject to supply chain issues. Typically, starch comes in large bulk bags, and we wet it with cool water. We then use steam to jet cook the starch to a specific temperature for a specific time, so that it can be used or injected into the paper machine, either into the furnish or used as a surface coating in the size press. Also, with regards to starch slurry preparation, It's important that we always keep starch slurry in movement, as if it settles. It is a dilatant fluid, so shear thickening, which means that if we let it settle, it basically turns into concrete. So we always have to keep it moving, or we flush it out. And we can do that by either by pumping it and actually keeping the liquid in, the slurry in suspension, or using agitators in tanks to keep the slurry constantly in motion. Some other concerns with slurry is, how long we store it in a tank. We have to be careful about the power that gets added to the liquid if we're circulating it from a centrifugal pump. You wouldn't think that, but when we're pumping a fluid, we are actually adding some energy to it. If we have oversized pumps, then we could potentially overheat or heat the slurry, and it can start to pre-gel, which then creates some hygienic security issues in the tank, where we might have pre-gelled starch, which then becomes subject to biological growth. Other things to be concerned with is the water supply. It should definitely have some sort of a either chemical treatment or have some sort of a sanitation program, so that it's free of biological activity. All right, when we're using starch slurry into a cooker, we pump it into the cooker at a specific concentration, and that can be dependent on the type of starch. And we may pre-dilute the starch before it goes into the steam jet. And the steam jet is where we introduce steam to raise the temperature of the starch. One of the things that's important is we need to be careful about the amount of energy that we inject into the starch when we're steam injecting. That energy can potentially damage the starch, but we can also use that energy if needed to cook hard to cook starches. And so when we talk about starch, we've basically got granules of dry material. We wet it into a slurry or hydrate it. It's important that they're fully wetted. And like I said, if we slurry it with warm water, it will actually create a shell around the outside, and then the whole kernel is not wetted. When we hit it with steam, what we're trying to do is unwind this very complex chain, so that we have very long chains of starch, right? It's not like popping popcorn, but we're trying to unwind the starch so that it can do its job in the paper. Basically, starch is used as a glue to hold all the fibers together on the sheet, or it basically provides dry strength. Okay, so when it's used as an internal starch in the furnish of the paper machine or in tissue, we want it to be very long, and so that it can provide its maximum efficiency. Starch is a very expensive commodity. It's one of the more expensive ingredients used in paper and tissue. So it's important we treat it gently so that it can be properly applied onto the sheet. Like I said, if we cook it with too strong of a action at the jet, then we can actually damage the chains so that they're shorter and then are not as effective. One of the ways that we can decrease the energy used at the jet is to cook at a lower solids. Some of the technical numbers around this is typically we're preparing a slurry at 32% or 22% solids, and that's a suspension of the dry starch in water. We don't ever want to go above 32, because once we hit 42, the material becomes shear thickening and we cannot pump it. So it's important we keep it well below 42% so that we don't have operational issues. So we take the 32% or 22% solids slurry, and then we pre-dilute it before the jet, typically to 6 to 8% solids, and then apply steam to heat it to the prescribed temperature. Typical temperatures for starch cooking can be anywhere from 230 degrees Fahrenheit upwards to about 265 degrees Fahrenheit for wet end starch. Once we cook it with the steam, it's held in a retention coil under pressure so that we can maintain the temperature. Once it reaches the end of the retention coil, we release the back pressure and then actually quench the paste with cooling water to reach the target solids, which is typically around 4%, but it depends on what the paper machine needs on the furnish. It could be anywhere from 2 to 4% final concentration. Some of the tools that we use on higher concentration starches, for instance, for size press applications, we might cook for a final solids of 15%, which is very high, but we can actually start out at about 12% at the jet, and then once we cook it at temperature, which is a little bit higher typically, usually 265 to 305 degrees Fahrenheit, we would then go to what's called a flash chamber. So we take the hot paste and we inject it into a flash chamber, which allows the excess steam to evaporate, which then raises the solids of the final paste. So typically that paste would go into a flash chamber, the excess steam will evolve, and the paste will drop out the bottom, and if we need to, we may trim the solids with a little bit of water before it goes into a storage tank to be held. Typical storage tanks are insulated and may have heating capacity depending on the environment and geographical location of the paper mill. If it gets too cold, we don't want the starch to gel or retrodegrade. Some of those terms are set back, where the starch can actually revert back into a gel, and then plug piping, which is a very common issue in paper mills that don't have some routine maintenance programs involved.